Okay, everyone, welcome back to section 2.7. Let's talk about some of the applications of these inequalities and how this is going to work. So we've got a situation here. We're told that the length of a rectangle is 3 meters less than 4 times the width. And then it says further that we want to express as an integer the maximum width of the rectangle when the perimeter is less than 74 meters. Okay, well, there are a couple of things going on right here. The first one is this first sentence. The length of a rectangle is 3 meters less than 4 times the width. You recall earlier on in our discussions on problems such as these, we said, well, let's take our length. Let's take our width. What is the relationship we know? Well, the length is, we read the word is as an equal sign. So the length of this rectangle is 3 meters less. That means we're going to subtract 3 away from something. What are we subtracting? Well, 4 times the width. So our width is W. So let's call it 4W minus 3. That's the first part of this. Now, of course, the second part of this says that expresses an integer the maximum width of the rectangle when the perimeter, let's call the perimeter P. Perimeter is less than 74 meters. Right. Well, how do we express perimeter? Well, for any rectangle, of course, we know that the perimeter formula goes 2 times the length plus 2 times the width. Please review that video if you don't remember it. Our perimeter here, then, we're saying, well, 2L plus 2W is less than 74. Right? Again, we can key in on this key phrase right here, is less than, so is less than. But L can be replaced with 4W minus 3. So we're going to go ahead and make a substitution right here into this inequality. So we only have one variable. We'll have 2 times L, which is now 4W minus 3, plus 2W. And again, that is all less than 74. Now we've got a nice inequality in one variable that we can solve directly. So let's go through the algebra. We distribute the 2, we're going to get 8 times W minus 2 times 3, which is 6, plus 2 times W is less than 74. We should simplify on the left-hand side as much as possible. We do have two like terms, 8W and plus 2W. So it's the same as writing 10 times W minus 6 is less than 74. To get rid of the 6 on the left-hand side, we add 6 to both sides of the inequality using our addition rule. By adding 6 on the left, we get rid of the constant term, leaving us with 10W. By adding 6 on the right, we get 74 plus 6, which is 80. So if we divide both sides by 10, we get W is less than 8. All right. Now, does that actually answer the question? Well, it says express as an integer the maximum width of the rectangle. Express as an integer. Well, the maximum width of this rectangle, then, what should we say about it? Is it 8? Well, not exactly, right? Because the width must be less than 8. So if we want to express as an integer the maximum width, we could say W equals 7 meters. Right? That is going to be our maximum width right here if it meets two conditions, right? The conditions were that it is an integer, right? 7 is certainly an integer. And the only way that integer is, the only way that value works is if the perimeter is less than 74. And we've just shown that the perimeter is less than 74 when the width is less than 8. So the width must be less than 8. All right, so if it meets those two conditions, that it qualifies as our answer. In this case, that's it. That's all we could say about this. So you do have to be very careful to think about the way that you express the answer when you're given a problem like this one.